In this part, we're going to look at the second part. How can we use the laws of logs to take an exponential relationship, and we'll look at that in a second, and turn it into a logarithmic one, or one that will produce a straight line for us. So we're going to use these laws of logs to first transform or work out what we're going to do to your original values to be able to give us a straight line interpretation. So what's an exponential relationship? Well, it's one that looks like this. Y is equal to AB to the X. And again, we can do ones that give us values if you want, but if you already have the values, there's no need to do this. We basically want, given a table of values, to work out the values finally of A and B. And we'll do that in class next week. At the start, I just want to make sure that you can draw the graph for yourself so that you get a straight line. So the relationship between the values x and y in the table is thought to be an exponential one like this, where a and b are the positive integers. We have got to find what a and b are. The table that we are given is this: x values of 0, 1, 2, 3, 4, and y values of 2, 6, 18, 54, and 162. If we were to plot them just as they are, as in the x and the y, we'd get something like this. We would get that familiar graph that goes sweeping up and towards the right, and when you see a sweeping graph up and towards the right like this, you might think to yourself, well, that linear scale isn't going to work. So what about using one of these logarithmic scales? It's a good idea, but we may not know how to do this in any way, shape or form. Well, I'm going to show you how you can take apart this expression using the laws of logs. At the end of the day, though, you only have a couple of relationships with which to memorize or be able to follow, and you could just use the initial relationship and the log expansion if you want, and just use that information, which we'll go through at the end. But I'll take you through the laws of logs. Our initial equation was y is equal to ab to the x, and we're going to use a bit of an arrangement or rearrangement using these laws of logs. You may know from algebra or otherwise that if you do the same thing to both sides and apply it to everything on both sides, you will still get a balanced equation. So if we take logs of both sides or put a log on both sides, on the left hand side we'd get log y instead of y, and on the right I'd get log of ab to the x. Now if you did some of the exercises that were in that little sheet of the ones we'd taken apart, well, the right hand side is a multiplied by b to the x. And it turns out that log of a multiplied by b to the x, well, I can use the opposite of the product rule, or make that log a plus log b to the x. So taking the things that are multiplied and making them in addition. And then using the power law, you can see that our log b to the x, I can move the power round to the front and get x log b. So on the left, log y doesn't change anywhere along the ways. I have x log b and log a. Happy days. Well, why is this important, Chris? Why is this a thing? Well, as it turns out, we can see that we had y and x values in our original table of values, like here. We had x and y. If we want to know what to apply, we just need to look at our new relationship and go, well, are they still x or y? The x stays as an x. Great, we don't need to touch the x values. But the y, if you look at it, is now a log y. And this basically tells us that if we take a log of the y values and then plot them against the x, we should get a straight line. Now, we are going to take a log of each of these y values, and like before, we're going to do log to the base 10. So log to the base 10 of 2, log to the base 10 of 6, log to the base 10 of 18. You pop those into your calculator and see what you get. You should get something like the following. You should get log 2 to be 0.301, log 6 to be 0.778, log y to be, or log 18 to be 1.255, log 54 to be 1.732, and log 162 to be 2.21. We are now going to plot the x versus the log y in graph paper and see what kind of relationship we get. If we do that, you will see we get a straight line like follows. And that is a result. That is exactly what we were looking for. And in the next lesson, we will see how we can use this for measurement. We can get a straight line, we can measure things from this straight line, specifically where the graph cuts the y-axis, and then a thing called the slope. A slope gives a measure for rate of reaction in science or in any kind of experiments, and that can sometimes be very, very useful. More importantly for the question, it gives us a way to measure A and B. This method works for equations, two similar looking equations of y equals a b to the x and ax to the b. Now, you can either pull these things apart yourself or recognize that if you get a question of y equals ab to the x, it will give me an expression like the one on the right, log y equals x log b plus log a. That is the one that we've just done, and you can plot log y versus x, very important. Or if it's ax to the b, we're going to plot log y versus log x, because the log y is equal to b log x plus log a. If you look at your y value, it's now a log. If you look at the x value, it's now a log, and it gives you something to plot. Once you've got those done, you can take appropriate logs. So calculate log y instead of y for ab to the x, and for ax to the b, calculate logs of both before plotting them. Then you can just plot your graph, and step 4 onwards we will do in class. I implore you to try a couple of these yourself. It's important that you try a couple of these yourself, because we have one final example to go through that is on the face of it exactly the same steps, but looks a bit more complicated, and unless you've tried and done this yourself, you may find yourself getting a little bit lost. If you have any questions, you know where to hit me up, get in contact with me, and I'll try and clear anything up. Okay, speak to you soon. Take care.